go over a couple problems dealing with own price elasticity of demand. And we're going to start out with this, basically the definition. Own price elasticity is going to be the percent change in the quantity demanded over the percent change in the price. And we know that the value of this will always be negative. Coefficient value will always be negative. And it will always be negative because whatever direction the price changes, if the price goes up, then the quantity demanded is going to go in the opposite direction. It's going to go down. If the price decreases, the quantity demanded is going to increase. They're inversely related, price and the quantity that's demanded. We know that from our law of demand, that downward sloping demand curve. And so, for example, if the coefficient of own price elasticity was negative 1.2, and I gave you a change in the price. Let's say the price decreased 5%. Then what's going to be what's the percent change in the quantity demanded? And that's fairly straightforward. We can just multiply both sides by 5%. A little algebra. Those will cross out. And so our percent change in the quantity demanded is going to be 5 times negative 1.2. So that should be percent change in quantity demanded is going to be about 6%. Now the other way I could set this up, instead of giving you two of these three values, the other way I could set it up would be to give you a starting price and a starting quantity that's being consumed, and then I could change the price for you. Say, okay, we went from price 1 to price 2, and then the quantity demanded went from the quantity demanded 1 to the quantity demanded 2. So let's just say that there was a price that it started at $5. Let me erase this. So if we started at a price of $5, and then the price increased P2 to $7, and the quantity that we demanded originally, let's say that Q1 is going to be 150 units, and then the new quantity demanded is going to be 100 units. And so this was our original price and the original quantity that was being purchased, and then the price increased, and as we know from our law of demand, when that price increases, the quantity demanded is going to have to drop. So how would we figure this? How would you get this squeeze this into this formula? And that becomes a little bit trickier. If we're not using calculus, we have to have some other way to go about finding the percent change in the quantity, depending on where we start. If you start at one point and somebody else starts at another point to calculate this, those percent changes can be thrown off. And so we'll use another equation, and that equation is Q1 minus Q2 times P1 plus P2. And then we're going to divide that by P1 minus P2 times Q1 plus Q2. And that's going to be equal to, or approximate, this coefficient, own price elasticity of demand coefficient. There are other ways to go about that. That formula is in your textbook. There are other ways to calculate it, but that's the way we're going to do it. And then we all agree to that, and we'll all get an approximation, get an estimate that's pretty close. And so if you plug these numbers in, you should get 150 minus 100 over 1 minus 100 times 5 plus 7 over 5 minus 7 times 150 plus 100. And then you get about 600 divided by negative 500, so you get a negative 6/5. And so if you choose the right answer, the answer that's closest to that, I don't think I got that exactly right in the one of the possible answers, but yeah, get close, and we'll call it even. So hopefully I helped you. This is a really important equation, and it wouldn't be that important if we were to use calculus, but I think we can all agree that we want to keep calculus as far away from this class as possible. And so you memorize this equation, and you know that, well, that's another way of solving for this equation. Depending on whether I give you 2 pieces of information and you solve for the third, or if I give you 4 pieces of information, then you can solve for the 5th piece of information. So I hope that helps.